Most of the problems in section 3.3 at some point will ask me to find an equation of a line that has certain characteristics. Before I plunge into the section, I'm going to pull a sheet that I flashed on the screen when we were doing section 3.1 because we've done a little bit more with lines, and maybe this will make more sense, and there's something new on this sheet that I need to mention anyways. So we're focusing on lines in this section, and in section 3.1, when we started graphing, we graphed equations, maybe in the form 6x plus 12y equals to 18. We plugged in 0 for x, plugged in 0 for y, got a third point. This is called a general form. When we get into section 3.3, when our goal is to create an equation for a line, the general form isn't very handy in terms of helping us create an equation. That form exists, but we're not going to use it in this video. The next form is the y equals mx plus b form. This is a super powerful form, like y equals to 3x plus 5. And I should know that the slope of this line is 3. The y-intercept is the point 0.05. And I should be able to sketch a graph of that just by plotting 5 on the y-axis and using the slope going up 3 over 1 to create the line. So this is an example of slope-intercept form. And slope-intercept equations, or the slope-intercept form, is going to be used a decent amount in this section, but not as much as the third one that we haven't got to yet. If my goal is to create an equation of a line given some data, more often than not, I use the point-slope form. The point-slope form of a line, it says y minus the y-coordinate of the point given equals the slope times x minus the x-coordinate of the point given. Something like this, y minus 7 equals to 4 times x minus 2. This is considered an equation written in point-slope form. When I'm asked to do the algebra to find an equation for a line, I'm either going to use the slope-intercept form or the point-slope form if the answer needs to have both an x and a y. And I use the point-slope form more than I use the slope-intercept form. The general form, for today, we're not really going to look at it because it's not useful in creating equations from given data. The slope-intercept form and the point-slope form are very useful to create equations given data to model situations. The last two forms, we've beat these on a little bit. Horizontal lines have an equation y equal to some number, like y equal to 7 would be an example of a horizontal line. Vertical lines are written as x equal to some number. If I need to create an equation of a horizontal line, or if I have to create an equation of a vertical line, then the problem probably doesn't have a bunch of algebra. It's probably more of a logic problem. So most of the problems today are going to use the point-slope formula, and I'll introduce it in a minute. But the first few problems use the slope-intercept form. The first few problems give me some information about a line. Let's do maybe number 1 together, because I think I can check number 1, show you how to check it better than I can number 2. So number 1 says use the slope-intercept formula, and part of the reason I just flashed that sheet up is so that I knew when it says use the slope-intercept formula that it means use the y equals mx plus b formula. And then it says use the formula to find the slope-intercept form of an equation of a line with slope m passing through the point xy. That's a pretty impressive sounding problem, and when I was a student I probably really wouldn't know what that asked me to do, but I can tell you because I've taught the class for enough years. In problem 1, what the problem is asking me to do, it's asking me to use the y equals mx plus b equation to create a line so that if I graphed it, it would have a slope of -3 and it would pass through the point -2, 4. So I'm going to create that line using the y equals mx plus b form. So when I go to write my answer, I know 100%, I'm told to write an answer in slope-intercept form. My answer needs to look like y equals mx plus b. The plus sign might be a minus, but it needs to look something like this. Have a y on the left side of the equation, a number times x on the left-hand side, right-hand side of the equation, followed by a plus or minus a number. In my answer, because this line needs to have a slope of -3, I know in my answer there's going to be a -3 that goes in front of the x. So often when I ask questions like this, students get lazy and they would just do this. They would just take the y coordinate of the point that's given and they'd say, oh, this is my answer. Well, if you put the slope in, right? Slope is -3. How do I know whether that's the right answer or not? I know super easily that that's the wrong answer. Let me get some graph paper to show you. For my answer to be correct, I need to be able to graph the line and it has to go through the point -2, 4. So let me graph this line that I just created and show you that it doesn't go through the point -2, 4, that that's not the right answer. So my checking, and I'm not going to check many of these, probably I'll only check this one. I'm going to graph y equals, and I'm going to emphasize -3 over 1x plus 4. To graph this, I'd go 1, 2, 3, 4, mark 4 on the y-axis, that's the y-intercept, and then I'm going to go down 3, right 1. So I'm going to plot 4 on the y-axis, and then move down 3, right 1, because the slope tells me to move that way. So I'd go down 1, 2, 3, right 1, draw my line. My answer is right if the line goes through the point -2, 4. Here's -2, 1, 2, 3, 4. In my line, it misses that point by a ton, so I know my answer isn't correct. So I need to refine my answer. The -3 in front of the x in my answer, that's good, because I have to have a slope of -3. I need to do some work to get this number to make it so when I graph the line, it goes through the point -2, 4. And that's actually not that hard to do. I'm going to use the slope-intercept equation, y equals mx plus b, and I'm going to take the information that's provided, and I'm going to start plugging it in. I'm going to take the slope of -3 and plug it into the x, I'm going to take the slope of -3 and plug it in for the m. I'm going to take the y-coordinate of the point 4 and plug it in for y. I'm going to take the x-coordinate of the point -2 and plug it in for x. So I'm going to take the information that's given. I'm given an m, an x, and a y. I'll plug them into the equation, the y equals mx plus b equation. And then I'll do some algebra and solve for b. Algebraically, this gives me 4 equals 6 plus b. So that's going to give me -6 minus 6, -2 equals b. Let me cross out this bad answer and put in what I think is the right answer. In my answer, there has to be a -3 preceding the x because the slope is -3, and my algebra tells me that the y-intercept must be -2. Now let me try to do this graph to check. So in order for my answer to be correct, if I take and graph the equation that I came up with, the graph absolutely has to go through the point -2, +4. So let me graph this. I'm going to plot negative 2 on the y-axis. So negative 1, negative 2. That's the point 0, negative 2. And then I'm going to use the slope. The slope is negative 3 over 1. So I'm going to go down 3 and write 1. So from the number that I plotted on the y-axis, go down 1, 2, 3, write 1, and now I'm going to connect my points. And this one I know is correct because the line goes through the point that it needs to go to. Whereas in my wrong answer, when I graphed my wrong answer, I didn't even pull out a ruler, but when I graphed my wrong answer, it didn't go through the point that it needed to go through. So that's the way I can check. It's going to take me a year to check every one, and I usually don't check these, but you can. If you're patient, you can check every one of these. So each of the first 6 problems has exactly the same skill set. It gives me some information about an equation of a line, and it wants me to build the equation that fits the information. So let's do 4 together. For number 4, I'm supposed to use the equation y equals mx plus b to create an equation of a line that has slope 11 and it passes through the point negative 2, negative 5. I know 3/4 of my answer. I know I need y equals 11x because that's slope-intercept form with a slope of 11. I just don't know the number to plug after the x, so I'm going to take the values that are given. I'm going to plug in 11 for the m. I'm going to plug in negative 2 for the x. And I'm going to plug in negative 5 for the y in the y equals mx plus b equation. I'll just do the algebra that's necessary now. So I'm going to get negative 5 equals negative 22 plus b. I'm going to add 22 to both sides to isolate the b because that's what I need to finish this up. I need to know what the b is. The numbers on the left-hand side have opposite sides, so I'm going to subtract. On the right-hand side, I'm going to cancel the 22s and be left with a b. I'm going to just put that b into what I'm going to call an answer. It's positive, so I precede it with a plus sign. That would be the answer to number 4. So this is easy, but so many students that use this method, they do what I did for the first problem. They don't do this work. For whatever reason, the other method's going to seem more complicated, but I rarely get students making mistakes using the other method that we're going to learn here in a second. Students all the time do horrendous algebra or horrendous things. They don't do the algebra and they write a wrong answer. Snuck some fractions in here. That's because lines can have fractions for slopes. And just use your calculator to push through the fractions if you're not comfortable doing the fractions by hand. I would rather have accuracy here. So, I know that my answer in problem 6 needs to be in the form y equals the given slope times x, and then either plus or minus the y-intercept depending if it's positive or negative. So I know most of my answer, I just don't know what goes after the x. To figure out what goes after the x, I'm going to take the y-coordinate of the point, 5, and change the y to 5 in the y equals mx plus b formula. I'm going to change the m in the y equals mx plus b formula to 2/3. And I'm going to change the x in the y equals mx plus b formula to 1. And I need to do the algebra to solve for b. So let me clean up that right-hand side. The right-hand side I have 2/3 times 1, which is just 2/3. I'm about to get the b b is going to be 13/3. It's certainly not impossible to even do fraction work in your head. But if you're not comfortable doing the work and you're going to make a mistake, just use your calculator. 5 minus 2/3 is 13/3. I'm going to put a plus sign in my answer because the b is positive, and I'm going to plug 13/3 in. This would be monsterly hard to check by graphing. I'd probably have to use a computer program to get the precision in my graph because I don't graph fractions so very well. So first 6 problems, that's all there is to the first 6 problems. I simply just take the information that's given. I'm told to use the slope-intercept formula. I plug the information in. That gives me the answer to b. I use the m that's given along with the b that I calculate to create my equation. The difference in the next few problems, if you look at the problems, they don't look any different. If I look at problem 7 and problem 5, other than problem 5 has a fraction and problem 7 doesn't, they'd look the same. And I could solve problem 7 like problem 5. My goal is to create an equation that passes through the point -1, -4 that has a slope of 2, and there isn't anything keeping me from doing what I just did, but the instructions are telling me to use the point slope formula. So this is the alternate way, and this is the way that students make way less mistakes on. Solving the problem like I did for the first 6 problems, I had to know that the algebra didn't give me the answer. The algebra gave me the component that I was missing for the answer. Point slope formula gives you the whole answer. So let me solve problem 7 using the point slope formula, and I'll check it by graphing. So for number 7, I'm going to use the point slope formula. Y minus the y coordinate of the point that's given equals the slope times x minus the x coordinate of the point that's given. I'm going to leave the y and the x that aren't subscripted as y's and x's. The points that's given are going to replace the subscripted y and the subscripted x. So in for the y1, I'm going to plug in -4. So I'm going to get y minus -4 on the left-hand side of the equation. When I have double negatives, I usually make those double negatives pop with a parentheses. To the right of the equal sign, I need to plug a 2 in for the m, and I need to plug in a -1 for the x1. So the point that's given goes in for the subscripted points. That's using the point slope formula to get started. Now I just need to do the algebra to isolate the y. On the left-hand side, I have a double negative that I'm going to make positive. And on the right-hand side, I have a double negative I'm going to make positive. I'm going to clear the parentheses on the right-hand side. I'm going to go 2 times x is 2x, and 2 times 4 is 2. I'm almost done. The nice thing about using the point slope formula is the algebra gives you the answer, unlike using the slope-intercept formula where the algebra gives you numbers that need to be plugged into the answer. I claim this is my answer, and I'll check this, but this will be probably the last problem I check. I need more graph paper. So to check this, what should happen is that my line should go through the point -1, -4. So on my graph, I'm going to show the point -1 for x, -4 for y. And if my graph goes through that point, because I know I have the slope right, I should be good. I am good. So I'm going to graph y equals 2x minus 2. I'm going to plot -2 on the y-axis. And then I'm going to use the slope, which is 2 over 1. I'm going to go up 2 and right 1 from that point. So up 1, up 2, right 1. And now I'm going to connect the 2 points. And fortunately, the line that I'm going to draw goes through the point that it needs to go through, so I know my answer is correct. So you can check every time, but quite honestly, checking is unless I have technology at my disposal. So I'm going to do problem 10. Exactly the same instructions. Use the y minus y1 equals m times x minus x1 point slope formula along with the provided information to find the equation of the line. For myself, I'm going to plug in, and problem 10, 1 for the y1, 3 for the x1, and negative 6 for the m. And just do the algebra to solve for y. So I'm going to go y minus the y coordinate of the point 1 equals the slope negative 6 times x minus the x coordinate of the given point 3. I would get the same answer if I used the strategy that I use for problems 1 through 6. But like I said, I have way better luck using this method. I'm going to clear the parentheses on the right hand side by going negative 6 times x, and I'll get negative 6x when I do that. And then I'll do negative 6 times negative 3. I'll get positive 18 when I do that. So now I have the parentheses cleared. I just need to isolate the y by adding 1 to both sides. And my answer is going to be what remains. On the left-hand side, I cancel the 1's. I'm left with a y. On the right-hand side, I get negative 6x plus 19. I could theoretically graph that. Plot 19 on the y-axis, go down 6, right 1, draw a line, and it needs to go through the point 31. One more. Let's deal with a fraction. And I'm going to use my calculator to push through the fractions. So I'm going to do problem 12 just like I did the last 2 problems because the instructions tell me to use the point slope formula. In general, if you're asked to find an equation of a line and you're given a point in the slope, you have your choice of the method that you want to use. So I'm going to take the provided information. I'm going to attempt to take the provided information. Plug it into the formula for y1, m, and x1. And then start simplifying. And this is the hard part. On the left-hand side, it's easy. On the right-hand side, one part is easy. To multiply negative 2/3 times x, you just write them next to each other. The other part, I'm going to pull out my calculator to do negative 2/3, which is the slope, times the negative 8 inside the parentheses. I'm going to get positive 16/3. So after the negative 2/3 x, I'll write a positive 16/3. And now I need to add 3, add 3. That 3 is really 9/3. So on the right-hand side, I'm really doing 16/3 plus 9/3 and getting 25/3. That's for those of you that can just rock math in your head. For those of you that that's going to be too complicated, just do that. Here's 16/3 plus 3, and there's the 25/3 that I put in my answer. Alright, so that's got to be good for part 1. We're probably going to move on to a part 2. I know we're moving on to a part 2, but there's probably going to be 3 parts to this video.